what actually is the metaverse?
The metaverse.
The metaverse. The metaverse.
Let's talk about metaverse.
The metaverse is the next chapter for the internet.
If you haven't been living under a rock, you would probably have seen my other channel and know that we were one of the first few people in India to get access to the Apple Vision Pro. In fact, I put it on and walked through Indiranagar in Bangalore, and that became national news. I have no idea why. But contrary to popular belief, I happen to believe that most of the use cases in AR and VR that make serious money will be business use cases. In fact, I'm not the only one. Mark Zuckerberg has been building a suite of business software, the virtual equivalent of a business suite inside of the metaverse. And he's been doing this for quite some time. It started when he allowed the ability to map your real-life keyboard inside virtual reality and then also assign a virtual desk and a virtual chair. Then Meta built out conferencing tools, whiteboarding tools, and all of that. But none of that really got the metaverse as popular as Apple and its announcement of the Vision Pro. And today, I got my hands on a report by Deloitte, which actually talks not about the consumer metaverse, not about games or simple apps for people like you and me, but for apps and technologies for companies, especially manufacturing and automobile companies. And in this video, I'm going to deep dive into the report. This is one of those fields where there are so many open opportunities, where there is a gold rush coming, and this video will detail many of those opportunities for you. Without much further ado, welcome to Breakdown. So in May 2023, Deloitte, along with the Manufacturing Leadership Council, embarked on a study where they ran lots of surveys with senior leadership of several manufacturing companies. They asked leaders in these companies what their thoughts, ambitions, and goals are in the fields of talent, supply chain, customer, and production ecosystems. And they also asked questions around companies' investment plans. How serious are they about the industrial metaverse? And what are the applications that are really going to boom? Before we go any further, let's quickly define what they mean by the metaverse, because everyone these days seems to have their own definition. What they mainly mean is augmented reality and virtual reality applications, what people generally tend to call extended reality or XR. Mainly, the ability of all these devices to render 3D worlds and also render 3D objects inside of the real world. That is what they're talking about when they talk about the metaverse. Now, what's the industrial part? The industrial part means these applications have to be useful for industry, which is manufacturing. It could be automobile manufacturing, it could be a food plant. And what we also learned from this report is that this also applies to fields like real estate. Anywhere where in the real world there is a 3D space, that 3D space can take advantage of the industrial metaverse. Wait, we have a surprise gift for you. We are giving out an in-depth report on the salaries for every role at Indian companies. This includes the real numbers, what someone starting out earns, and what you can expect at a CEO position. But here's the catch. This report will only be made if you guys take us to 100K subscribers. So help us get to that milestone so you can get access to the real and authentic salary figures across India. Don't miss out on this. So there are 5 major findings from this Deloitte study. Number 1 is that most manufacturers are optimistic about the potential of the industrial metaverse and are confident in its adoption in the manufacturing industry over the next 5 years. Number 2 is that on average, manufacturers are currently piloting or using more than 6 industrial metaverse use cases through the production, supply chain, talent, and customer ecosystems and are already realizing benefits in their costs, revenue, operational efficiencies, and talent. This is not something that companies are saying, oh, I will do 4-5 years later. They are already piloting many of this technology. Number 3 is that executives are expecting a 12 to 14% increase in throughput, and they're also expecting to invest significantly. Number 4 is that many of these companies are actually very concerned about cybersecurity and data protection in a world where you can have full view into your plant or your factories. How do you keep secrets from competition? How do you keep secrets from leaking to the public? All of this is very important when you're building this technology. The last thing is a cohort, which is a group of people who are already pace setters, that is, people who have already kickstarted this, exist in this space. Their strategies, what has worked for them, and other leading practices are the gold standards in this space, and we are going to break down some of them. So first, let's talk about technology. Before we enter the metaverse, a survey was done on what technology do you use today in manufacturing? And number 1, without a doubt, was data analytics. What are we actually doing? How much are we producing? How much is it growing year on year? That falls into data analytics, and pretty obviously, many companies are actually already implementing data analytics. this. This is in close competition to cloud computing, which is putting your data on the cloud in servers rather than hosting them offline, which stands at 37%. Then there's the Internet of Things, which is sensors, devices, and platforms that are all connected to each other. And the Internet of Things, as we all know, is getting smarter. If there's a camera looking at all your factory workers, that is now connected to the cloud where it's uploading information to the cloud. Then data analytics and AI can be run on it, and all of this works pretty holistically. The next thing is digital twins, 3D modeling, and 3D scanning, which stands at 13%, 5G technology, which stands at 11%, AI, which stands at 10%, and then that's followed by edge computing, wearables, extended reality, and the blockchain. But let's zero in on three parts of this, which is all the 3D stuff, the digital twins, and the extended reality component. What is inside of this? 92% of surveyed executives said their company is experimenting with or implementing at least one metaverse-related use case. And on average, they are currently running 6. Here's the breakdown. 34% are using this in production, 21% in customer interaction, 21% in supply chain, and 17% in talent. Now let's break this down. Let's go through the exact use cases. In production, as we can see, process simulation, which is, can we run a 3D simulation of this on a computer before we manufacture it in the real world? This stands at 30% of people who are already implementing and 29% of people who are experimenting. Next is the real-time monitoring / digital twin. And I'll tell you what the current version of this and what the eventual dream of this is. The current version is you have basically a 3D camera on wheels. And let's say somebody very far away, somebody sitting halfway across the world, can use an Xbox controller, and on his or her TV, he can control the robot to go wherever they want. And they have a 360 camera so they can look all around. The dream to this is eventually you're wearing a headset and you're able to look fully around and you are controlling a robot in the middle of your factory or your plant, and you're able to see and inspect everything. Remember, after you've built a successful factory or a plant, inspection and quality control become two of the most important things, because as we all know, humans and even robots today are pretty unreliable and somebody needs to actually keep an eye on them. But because many of your executives don't actually live in or near the plant, they live in a different area of the country where they have to actually meet other people to sell, they want to be able to remotely put an eye in the plant that they can control by themselves. And that is what we call the digital twin or real-time monitoring. 33% of companies are already implementing this and 24% are experimenting with this. The next thing is virtual prototyping, which is not just running the process and the simulation, but trying different prototypes in 3D to see what design has the most chance of working. And then there is factory simulation. Now I want to tell you something about factory simulation. We think in our head that factories are just conveyor belts. Something goes on a conveyor belt, some human verifies it and then goes to the next conveyor belt. That is a factory of 20-30 years ago. I want you to check out some factories and how they work in the real world today. As you can see, there are lots of different things going on at the same time, and somebody needs to simulate the entire factory to know what is the production capability. If you're producing matchboxes or matchsticks, how many can you produce per day? To do that, you actually need to simulate all the conveyor belts and all the technology and how much time it goes from point 1 to point 2 to point 3 to the human verification and so on and so forth. All of this needs to work seamlessly, and somebody needs to run this on a computer to be able to tell their boss, this is how long it will take for us to produce one matchstick. Next, they're using the metaverse in quality control and assurance. There's virtual maintenance. If you've seen the Spot robot that actually can walk around and do things for you, especially in harsh conditions, that can really come under virtual maintenance, where you don't actually have to be there, but you can solve problems with your hardware from a different location. Next, let's come to talent. In talent, one of the obvious use cases of VR, especially VR, is virtual training. And with augmented reality coming out, that virtual training is only going to become better. I'll give you two examples. Now I'm going to tell you something really weird. I have a friend who I've spent a lot of time with who's never actually flied a plane, but has spent a lot of time in virtual reality in a game called Microsoft Flight Simulator. And Flight Simulator has a mode called the hardcore mode, where you're actually controlling the flight, and many quality pilots actually go through this training before they get on a plane. I think if we're all going to crash and we're all going to die and something happens to the pilot, I would actually trust him to have the best shot. Maybe we'll still die, but I trust him to have the best shot at actually landing the plane because he's been through many of those simulations in an environment that is almost exactly like a real Boeing plane. Another use case of immersive training is, for example, in medicine. In the US, there's actually a shortage of cadavers, which are dead bodies that you can actually conduct mock surgeries on. This allows a lot of junior doctors in training to actually experiment and see where what is, and also be taught that by a doctor sitting in front of them, pointing at a particular location and saying, hey, this is the gallbladder. So all of that can not only be done in VR, but also in AR, where you just need a blank table and then you have sort of real character on it, and all of this is taught to you by a professor standing across you. Now these sound like fun and games, but the more realistic you can make the 3D environments and the experience, the more useful it is for many of these companies, especially for not so critical talent like nurses who don't need extremely formal surgical training but would really benefit from a virtual training session like this one. This also helps in manufacturing, where if there is a complex machine that somebody needs to learn to use and that machine is dangerous or an error could cost a lot of money, many of these people can be trained in VR. And the use case, the business idea for you is that you can actually go to very specific types of companies and build very customized solutions for those companies. Yes, this is one of those really high-ticket services agencies ideas, which is building a company that builds specific simulations for specific types of manufacturing companies to train their talent. In fact, 26% of people are already implementing immersive training and 26% of people are experimenting with it. Next, there's also virtual plant tours. This could be for sales. Maybe there's a relationship between a factory and somebody in quality control outside, but using a new technology called Gaussian splatting, using a regular phone, you are able to reconstruct an entire 3D world adjusted for scale for some other person to walk through. The best example of use cases here are in real estate, where some broker comes to you and he says, I have these 20 great houses on sale, but the person buying might actually be too busy to go check out all 15 or 20 and might want to shortlist them first by virtually walking through them. I know a lot of real estate companies in India are trying this to create a virtual 3D environment where potential customers can walk through. And one of our technology subsidiaries, which is EOS Labs, is actually currently in the process of building a POC with a real estate company to actually show you what this virtual walkthrough would look like. Then there's supply chain management, which through the magic of GPS, where a manager is able to look on a board of where all his delivery drivers are and where all his or her shipment items are, so they're able to make better decisions. Somebody once said that the best way to either learn something or make decisions is to first visualize this. And the entire value of the metaverse is actually allowing you to visualize things so that the person managing that thing can actually make better decisions. Lastly, with the customer, there is a potential for an immersive customer experience. And we've seen this a lot with automobiles. In fact, a lot of high-end automobile manufacturers have made immersive driving experiences of their cars. So instead of you going to the showroom and trying it, which most people eventually do, but before that, when you want to shortlist it or just see what the experience is like, you can put on a VR headset and actually sit in that Porsche and see what it's going to be like. And this is also very useful for aftermarket support, which is, suppose your car breaks down and stops working, and maybe you're in a very, very remote part of the world that doesn't have access to the right people to fix it. Somebody can, in virtual reality, show you where the different parts of the car are that you can fix by yourself or get a mechanic to fix. But now, what is the value prop of all this for the leadership to actually make these decisions and spend this money and try these pilots? Well, let's go through them one by one. When it comes to talent, the main thing was improved employee attraction and retention. You want to hire the best talent, you want to show them a view of the plant before they even get in, so you make them aspire to actually be at your workplace. That is something this helps with. And of course, talent really loves to be trained virtually because it's work from home and you can actually put on a headset and learn everything you can without going to the location. It's also a less riskier way for the employee to try out that hardware or technology without ruining the employer's expectations. In production, it's either reducing costs, so you're avoiding making mistakes, or higher throughput, which is how can you produce more of the thing that the factory is producing. With supply chain, of course, it's improved supply chain performance, which is faster delivery time and less customer problems when it comes to shipping a product from the hub to the actual end customer. And finally, with customer experiences, it's all about increasing revenue. So this would fall really under advertising or marketing, because advertising and marketing wants a customer to try out a BMW before they enter the showroom. I'm going to give you examples of each of these, and these are problems that are being solved in the US. I bet bet you that you can clone these solutions in India and find a market for these. So let's go through them one by one. With immersive training, a leading global aerospace manufacturing company is using AR, which is augmented reality, to guide its workforce on challenging and intricate production procedures. The company reports that productivity has significantly increased by using this approach. With virtual plant tours, for example, a multinational power management technology manufacturer is using AI technology for its engineers and staff to participate in virtual plant visits to conduct virtual Gemba walks. A large industrial conglomerate uses VR to appeal to a younger workforce's career fairs. Students put on VR headsets and can experience the company's products and technology, providing them with an inside view of the company's operations and inspiring interest. With production, a German automobile manufacturer is using digital twins to simulate and optimize virtual manufacturing. With product development, an automobile manufacturer is using VR headsets like a conferencing solution to bring engineers, designers, and even executives from all around the globe in an immersive virtual space with the car designer. In fact, I recently learned that Autodesk is building VR solutions, so a lot of manufacturing talent, especially engineers, designers, etc., can actually sit in a 3D space and build something. I can also see the use case of this for interior designers and architects because I've used the technology Twinmotion in the past and I can see how valuable it is going to be in virtual reality. A global automotive manufacturer's engineers are using AR glasses during the prototyping process to inspect the design for manufacturability of its vehicles. By conducting this validation work in AR, the company says it shaves off months of its product development process. Next, there's virtual maintenance. A global aircraft manufacturer is overhauling its maintenance inspection process by conducting fly-around inspections using a drone. So there's a drone, somebody's controlling with the next box from far away, thereby shaving off the time and the cost of travel. Lastly, there's virtual warehousing, as we've spoken about. A global logistics company has deployed AR for order picking in its warehouses. Graphics displayed on AR glasses guide workers through the warehouse and provide order picking instructions. So there are AR glasses and the AR glasses tell the worker what to do. This will be very valuable in India because a lot of, let's say, consumer delivery drivers, for companies like Swiggy and Zomato, many of these riders are actually riding and using their phone, which is extremely dangerous. Imagine having AR glasses that show them the path, and this technology is right here today. It's just not implemented at scale in a company like Zomato or Swiggy. These are open ideas. You can go build for this. So who is leading the way in this? According to the study, 30% of this cohort are what they call pace setters, which are people who are experimenting and trying these projects, and many of these pace setters are not doing it alone. They're working with key contractors outside. Like I said, there is now a market for a services company that builds some of these technologies for the industry. The average number of use cases in action of regular companies are about 5, but these pace setters, these companies that are on the edge, they have more use cases in action, 8 to be specific on average. Next, the overall budget for digital initiatives have gone up from $1.5 billion for regular companies to $2.9 billion for pace setters, which are companies on the edge who really want to integrate technology. The budget for metaverse initiatives at a regular manufacturing company is about $200 million, and at these pace setter companies, it's nearly $735 million. And like I said, many of these pace setters are very likely to work with external companies. The likelihood to form external partnerships among pace setters are much higher than others. For example, Industry 4.0 providers, which are cloud, IoT, and analytics, there's professional services firms, and there's physical automation and robotics vendors. Finally, they're doing all of this through organizational change, and there's a lesson in it for you as a business builder in this space. Most of these pace setters are creating a metaverse center of excellence. So there's a team inside a company which is focused on metaverse initiatives. Many of these people also have a roadmap, which is this year they're going to do this, next year they're going to do something else, the year after that they're going to do something else. And they also have initiatives to actually identify and assess the gaps between current and desired levels of technology adoption, which is these people are smart. They will measure whether what you built for them actually works or not. The reason I'm telling you all of this, which is when you go to a company in the US in manufacturing, there are now specific teams responsible for the industrial metaverse. They're all called different things. In some companies, it could be called the innovation centers. In some companies, it could be called the 3D centers. And in some companies, it could just be called the metaverse center. The point is, you have to go find it. Now, I don't know yet if these exist in Indian companies, but if they don't, they will be there in a few years' time. The lesson for you is find the leader, find the pace setter in these companies, because because that's the person that will get you enough buy-in. Especially selling to large organizations is about getting them to buy into your idea, and that's only going to happen if there's one very enthusiastic chap there who is willing to help you out, because they do need help. The top 3 challenges are cost to implement, lack of talent with the right skills and knowledge, and integrating with existing technology platforms and systems. These are all problems that an external service provider like maybe you could actually help out with. Like I told you in the beginning, with the industrial metaverse, cybersecurity risks are the biggest problems, and also data protection and IP. For example, if you have a training process and you allow all your employees at home to go through this training process, what's preventing that employee from leaking it to another company? There's also a brand and reputational risk, which is what if some part of your training process, while very, very important, looks very icky to the public. For example, there are many manufacturing processes which many people on the internet who tend to have digital jobs, they look at these manufacturing processes and say, oh my God, that's so much labor to put somebody through. Now, that is the reality of the world, unfortunately. We are the minority. The people with the desk jobs are still the minority. But if some employee leaks the training material or the virtual plant tour and says, look, this is how they treat their employees, then it could be a brand risk. So when you do sell to these companies, the first thing they're going to ask you is this going to damage my brand? Is there a cybersecurity risk? A risk that this is going to get hacked or data can leak? And finally, is my data and intellectual property secure from being leaked to competitors? 75% of respondents plan to increase their budget by 14% for metaverse initiatives. So this industrial metaverse concept is something that is ripe for disruption, especially in India. And if you're an enthusiastic software builder, even if you don't have experience in 3D, which if we're talking software is reasonably easy to pick up. I never really understand the normie need to divide software into so many different fields and act like there's no way that somebody who's gone through field A can learn field B. Because I know a lot of really good software engineers who can do regular full stack development and then move to blockchain, then move to AI, then move to game development. Because while understanding the market concepts might take you some time, learning how to build the technology, learning how to write code is not widely different between many of these different fields. In fact, I wouldn't even call them fields. For example, if you're an automobile company and you're using AI, then it's still AI used in the field of automobiles. If you're an automobile company using AR or VR, then you are not technically an AR VR company, you are still an automobile company. For example, the field that I'm in is content. But it doesn't matter what technology we use to make the next leap in content. At the end of the day, it makes a lot of sense to stay married to the field but not be married to very specific tools or technology. If you need to use a little bit of AR, VR for training and then AI for quality assurance to make one holistic product, why not? That's it for me. Hope you learned something. Subscribe to Breakdown. Bye.